Hi, it's Gadget UK here again, back for part 2 of the Archimedes A3000 repairs here. In part 1, I think I left it with a floppy drive problem. So let's have a quick look at this one. I've just connected the connectors there. I'll remove the battery. You can see some clean-up work has been done here. It's got new sockets here. This stuff's all socketed. These are socketed. It looks like it's got new sockets here. It's relatively clean. We've got a couple of fixed wires there. So we'll see if we can just pull this RAM board out. In fact, we'll get rid of the floppy drive first. That's the easiest thing. So with the floppy drive out, hopefully it might be a bit easier to sort of wiggle this out. They're not easy to get out, these, actually, because you've got 3 connectors. You know, you've got 3 strips there. So it's like, if you're not careful, you can pull it on one side and it starts to come up, and then you bend all the blooming pins if you're not careful. It's coming off there, look. I'm reluctant to pull it by the RAM chips here. It's coming up. You can test this separately. So far, I've got a 1 meg upgrade working that we pulled off that really super corroded board at the start. We've got 4 meg one working off that previous board we were just looking at with the floppy drive issue. There we go, it's coming off now. That's it. Yeah, so that's looking okay. Oh my goodness, well there's me thinking this was a nice moderate damage board. I mean, there's some corrosion underneath, I'll show you in a minute up top here a little bit. Look at the number of wires. Oh, this one's not going to be easy, is it? Well, if we ignore all the scary wires, we can clean some of that stuff up, and it's pretty tidy, to be fair. Whoever did that did a pretty good job, a very good job in fact. But learning what we did from the first one, this is where this is going to be super easy now, and I've worked at the fault already on this. So it starts there, the second pin missing already. So there we go, that's the connection problem. And the next one, we've got a join. So, and I've tested the others. So it's this second pin here should go to the third pin there. Let's just confirm that again. Yeah, that's right. So it's yeah, the third pin on the connector here wants to go to the second pin there. That's why the keyboard is not working 100% on this one. So if I fix that, we can clean up the stuff here. I mean, to be fair, there's very little to do. It's pretty tidy. But so 1 or 2 of the solder points and wires here I will redo. Can you see there, like that's just kind of like hanging on there? There's a few like that, and then we've got a few little bodges like this here, that just, and here, and extended little bits here. Look, they just need like bits trimming off and a bit of fresh solder, adding a bit of flux, get a nice little bead of solder on there. But yeah, an incredible amount of work has been done to this board. It doesn't fill me full of hope for the other boards, because is this what I'm going to be faced with, this amount of traces? I can't imagine I'm going to be able to fix all of these. I think I might have to, I don't know, send some out to some of the channels or something, 1 or 2 of them at least. So diagnosing connectivity problems around the keyboard section there can be a bit painful, if I'm honest. I think on occasion I did actually refer to the A3020 or A3010 schematics, because they're easier to read when you're zoomed in. You know, this is, if you look here quite close, you start to not be able to see some of the characters and things here, but for the most part you can see that says like 1, 2, 3, 4, 5, yeah, and then you've got Y, and then in brackets 0, 1, 2, blah blah blah. So IC4 and IC5, those 2 chips that just sit near the connector there, you know, and if you look at the wider diagram you can see where they go to on the ribbon cables over here. You know, there's 1 connector there and there's 1 connector there, but again the pin numbers are really hard to make sense of. Yeah, I had to swap the keyboard over because the ribbons are bad on that other one, actually. But I managed to clear the CMOS and then boot into this here, and all the keys are actually working, as far as I can see. The only one I'm concerned about is the caps lock LED, which I'll show you now. It's not very bright at all. There's a separate connector for that on, well, not separate, but it's one of the pins on the flex cable there, is used for that LED. So, and it is working, it's just not very bright. If I put it on caps lock, you'll see. If you type letters now, look, it's in caps. So, yeah, and all of the number pads working. I need to find a key test program of some sort that will do the function keys and things. There is a test, set of test runs for this. Number lock, yeah, that's working. So everything is working as far as I can see there. But if you look at caps lock down here, you can see it is illuminated. It's just not very bright. But then again, if you look at the num lock from the same sort of angle, that's not very bright either. It is kind of head on. Let's just have a look at that one head on. Maybe it's alright. Maybe I'm imagining things. It's alright, that. So I've connected up the floppy drive from the previous one where it wasn't working at all. So let's give this a try now. Yeah, seat back to track 0 there. I don't think it's reading it now, it's got a disk error. So the disk drive needs some work, but the fact it's seeked back to track 0, I'll show you that if I can. So I've just moved the head up here manually, and if I open the disk drive now, get ready, you will see it should go back to track 0. See that? That other drive is not doing that. It's just straight away saying there's no disk. So we'll try some of the other drives now. So this is interesting, it's like the curse of the floppy drive here. Hang on. This one's saying no disk in the drive. I think it wasn't sat in there. Let's try it again. It's doing it now. Please read it. Oh, disk error. I wonder if I've messed my disk up. I mean, this drive is really bad. You'll see in a minute, I'll show you it. The disks are not sitting very well into the drive. Yeah, it looks like I'm going to be faced with a number of these. Just watch. See how slow that ejects? It's just not, you know, the mechanism needs greasing and stuff. It's not going in properly. Well, quite frankly, it is beyond belief. I'll show you the pile of floppy drives we've got here. I mean, they are, maybe it's not that beyond belief because they are all faulty. There you go, there's the small pile of drives we've just tested. Now those aren't out of the other Archimedes units. These are just additional ones that were spare. Well, this one with the lid off, this is the first one we were looking at, the last 3000 that just wouldn't work at all. So none of these work, and actually I would say 50% of them say no disk, you know, no disk or whatever, there's no disk in the drive kind of thing. And then the other ones just give that same error you've just seen. So maybe there's nothing wrong with the floppy controller on that other motherboard. Maybe it is just the drives that are confusing things here. I think what I'll have to do is borrow one of the drives out of one of the 3010s, because I know those work, just to prove one way or another whether there's a floppy controller problem on this motherboard as well. Whoa! Finally, I have spent hours, about 5 or 6 hours this afternoon on this. Yeah, not just on this one drive, on all these drives, and trying to work out what's going on with which board here. So, recapped this one, 3 new caps on there, demagnetised the heads, cleaned the heads, lubricated things up, and it's working fine, as you can see there. So this was the second keyboard fault one. This is the one that I, straight away identified. I think it was like the second or third connection was broken. We fixed that. That fixed the keyboard. I put a decent keyboard on because the LEDs weren't illuminating on the other one, so I need to have a look at that other keyboard membrane later. It's going to be the edge connector, it's just going to need a bit trimming off, or some conductive paint putting over the edges of the things there. It should be okay. I'll show you that in a minute. But the main thing is we've now got one of these 3000s up and running. Still needs some clean-up work. This is the one with all the wires on that somebody else has had a go at fixing. Done a good job, but I'm just going to tidy it up a little bit, clean up a little bit. And then this one, I think, is 100%. So the other thing I'll point out here is initially I was testing with a high density disc, and you see we've got a hole on each side of the disc here, one in this corner, one in this corner. If you look at the drive here, you can see the 2 switches here, one for the discs, the detection to make sure there's a disc in, the other one for the write protect. But over here we have nothing. So the drives that go in these as default, the 3000 models, are double density drives. They're not high density. So that was part of the problem. I'll just show you what error you get when you put a HD disk into one of these. And I will admit that when you saw this same error previously, that's why. But that big pile of drives I showed you, they don't work. But this is the first one of them I've managed to get working. So I'll just work my way through them. I think they're all going to be mostly cleans and lubrications, but the odd capacitor will need swapping out in them. So coming back to the board with the floppy controller issue, I think it's the 1772 that's faulty. I can't see what down here would cause issues with the floppy drive. But the other problem we've got is the middle mouse button's not working. Now this mouse, it's got a problem with the cable. You've got to sort of press the cable that way there to get it to work, so that there's damage occurred here. So I'm going to take this apart, work out where the middle button goes to on here, so that I can easily work out where the damage is around here, because it's just going to be a trace again coming to and from, or from the mouse socket there. But at the same time, because I'm taking this apart to work out the connectivity, I'll strip back the cable here and fix this mouse at the same time. It'll just assist testing. The nice thing is it's got a standard 74HC 14D there. Can you see that? So with a bit of effort you can make one of these yourself. So I took the cable off, and again you could replace the cable. The green in my case went to pin 1 here. So if we probe between the middle button and the contacts there, we got short. So it's the 4th one down here is the middle, which goes to the red wire by the looks of things. So if we just I'll connect this back up. Now bear in mind I've got a faulty cable here. This cable is not working very well. So I stuck one of the probes into the red there, which is the middle button, and if we just probe around here, despite the cable being bad, you can see we've got a join here. So it's on the row of 4 pins, you can see that, and the middle button is the top, you know, the edge one there. Yeah, and then I've got the board just resting on here like this. I don't know why, but anyway, you can see then I can probe from here, and I can see it comes out through the socket here, so I know the socket's alright, and it comes down here and over here somewhere. Can't see where it goes. Yeah, anyway, I need to follow that trace from there. And actually that was simpler to work out than you might expect. So yeah, tracing underneath, it came out on this pin here. This I think is just a ferrite bead kind of thing. It's just like probably a 0 ohm link. Well, there's no short across this side, and it's kind of wobbly a bit there, so I think it's detached. We had a join there then, did you see that? Look. So yeah, this component is bad. Look, the pin's coming out, look at that. That's the fault. I'll just test these other ones as well, just to make sure they're alright. So I'm going to stick one of these in here, because they are pretty much a short through a core there, you know, ferrous, you know, stuff. Yeah, hammers is the same sort of resistance as those, so I think we'll be okay. I'll just stick that on there. So I use the solder pump there to remove the bit of the leg and the component itself. We'll just clean the pads up here with the fiberglass pen. Clean underneath it as well, because it's probably not had a bit of a clean just underneath it where the component sits on the board. And I'll probably just use a sharp tool on that pad there, just to scratch the surface a little bit to get it super clean. Then we'll fit this. So I'll switch it on and hold down the delete key, because it's not had the battery on it for a while. There we go. That's resetting the CMOS settings. All being well, we should have a middle button. So if we move the mouse around, funnily enough, after taking this mouse to pieces, it seems better actually. The cable's still not right. Yeah, it's definitely the cable, because if I move the cable it starts to move a bit better. But if we press the middle button now, yes, we've got the middle button again. Sweet. So apologies, it's not very clear this. You can see the floppy drive interface is on this side here. In between you've got one of those 7.4 series chips there, some gates, and a gate there. Just move this down, we've got another one of those chips here. So those are there's 2 chips next to the 1772. There's nothing else really around there that could be relevant, so it is either one of those 274 series or it's the 1772. From prior experience, I think it's going to be the 1772. I replaced this particular type of chip in many Amstrad PCWs back in the day, and old XT PCs and things like that as well. So before I commit to replacing the 1772, we'll look at this here, the HC00. I think this is a NAND. If we look at pin 1, it's a high, pin 2 is a high, so the output, pin 3 should be a low. And then we've got a high, so we should have a low. And it's the same all the way around. Well, it's not exactly the same all the way around, but you know, it's working, so we've got a low and a low, it gives us a high. I don't think you can be able to see the probe here. We've got a low, we should have a high, we do. So it's okay static. If we try to read the drive, this is the difficulty, because you've got to keep doing it multiple times because it takes so long to get on the right pins there, but hopefully you can see that's a high. And if we probe it, do you see it sort of flicker? but we never really saw a low. No, it could just be because it was for such a short period of time. And if we look at the pin next to it, we'll do the same with that one. That one remains static, I think. Yeah, that's static. And if we look at its output, bear in mind one of them is changing as we access the drive. We've got a low, so that should go high. And if we just watch it, hang on. You see it flashes, but it doesn't go high. Well, yeah, I mean, it's such a short period of time. But you would expect maybe a change there. You might see that on the scope. But, yeah, I mean, I don't think that's going to be it. But we'll swap that out anyway, because the only thing it can be is that, or that, I think. I could be wrong. There could be a trace somewhere down that end of the board where the battery is. I don't think so. I think this does have a floppy controller fault, because the head doesn't move back. You know, it's really weird. So we'll get that off next, socket that up. So we've got a brand new 74HC00 in there. Let's go and test it. I don't think this is going to fix it. I think the problem is this chip, actually. So this is the one I've classed as extreme corrosion, and you can see why. It's over the whole board, you know, there's just so much damage to this board. It probably can be repaired. I think all of these could be repaired, but I'm going to borrow the 1772 disk controller out of this just to rule it out, because this floppy controller error is driving me nuts. So I didn't show removing the faulty chip there, what I suspect is faulty, but you can see just using the desolder station here on the donor board. And we'll just get this chip off this way. On the other board, incidentally, I did actually just use the desolder pump. And then I freed it up with hot air just to make sure I wouldn't damage anything. But I've shown that technique so many times recently on other videos. Woohoo! It's finally working. I removed a little bit of the solder mask there on some of those smaller ICs just next to, you know, the tracers run right next to the pads there. It's quite hard to avoid that unless you've got super fine tip on your desolder station. But anyway, we'll clean all this up, give it a brush down. So a quick look after tidying up. We've just got the few fixes here, and it's looking pretty clean around here. So not looking super tidy around there. This resistor's got to come off here. I've now measured the battery contact 0 volts. This feeds the tab here, yeah? I think it's 180 ohms, 4.6 volts. But on this side of it there's nothing, so I think that resistor, well, it was one of the ones around here that needs swapping out anyway. I will swap these others around here later. But right now, this is the only other issue with this, that this resistor is not passing the supply across to the other tab. So if we just check that on continuity from here to there, no, it's not joined across, is it? So the trace here must be damaged. We're going to need a little wire, I think. So I've got further cleaning on the board to do a bit later on, but right now I want to try and reassemble this. In order to do that, I need to glue this mount here. Now what I should have done is made sure I had this the right way around before I try and stick it on, because there are a number of ways this could sit. Whilst that's gluing, I can start to screw it together. So the screw that goes into that top corner there is quite a lot smaller. As you can see, it's a really small screw, that one. So I'll connect the memory module up next. The eject button I didn't show you, but I forgot the cap was off. And what you can do is you can just pull the switch in so that it's pressed, and then slide the cap back into place, and then just press it on that way. Saves you taking the motherboard back out again, if or even just if you need to change it, because those reset switch caps do break, a bit like eject buttons do on floppy drives. So if I just carefully push this back into place, that's our 4 meg RAM module. I think the next thing I'm going to fit in there is this. This came from one of the other ones. Why not? Why not have this in there as well? So it's, as you can see, an analog port, HCCS user analog port module. So you've got a user port here, and an analog port there. So not really sure how best to get this in. Let's just disconnect the floppy drive and see if we can get it in that way. In fact, we'll disconnect the earth on the power supply as well, just because that's hindering us. It's not the easiest thing to get in this. I wonder if you're best off doing this when the board's out, actually. So I've no idea what these two chips do. It says internal expansion down here, and there's nothing much marking around there, marking wise. So I've fitted those. I'm now going to fit this. The difficulty with this is, well, it's difficult. It's difficult to try and fit. I think I've just about managed it there. Yeah, it helps if I remove the screws from here first, because I put those in there so I wouldn't lose them. Am I ever going to use the pod jewel or the those two chips I put in? I'm not sure. We'll research those two chips I fitted in a minute, just to see if I can work out what they're actually utilised for. Yeah, it's gone on one side, not on the other. There we go, second time lucky. So those two chips are related to the serial interface. The connector is on board. This is one chip here, and we can see TX parts and RX parts receive and transmit. It's like UARTs. So, and if I just move that up a bit, you can see it says socket. So there are two chips there. The one on the left hand side says 65C61. So that's going to be like the UART, I think, and then you've got like a receiver transmitter pair here. So booted up okay, the 4 meg's okay. I've just got a command prompt and type pod jewels, and we've got pod jewel 1 user / analog port. So back over to this one, we tested the keyboard out on here and it seemed to work okay, but that was with a different keyboard. So the keyboard that belonged to this one didn't work, and all I did is trim down a millimetre off the ribbon there. I'll show you in a second. I'm going to show you on a few of the others as well, because we're going to end up doing the same thing on these. You could recoat them instead of just trim them back, but to be honest, there's quite a bit of slack in these, so you can get away with cutting off 1 or 2 millimetres, maybe even more than that. I'll show you that later. But the caps lock is not working. All the keys are working now, but the caps lock isn't. Now I've just traced out the first connection here. That's where the caps lock LED goes to the keyboard. Now the caps lock key is working, just for the record, but it was just the LED not lighting. Everything else works. All the other LEDs work, all of the keys work. Just the LED for the caps lock not coming on. It comes from here, it goes down to a little wire there, I think, but ultimately it lands on this pin up here, pin 6 on the 7438 there. Goes via resistor, 220 ohms. So if you measure from here, but you're on resistance mode, which I just did, 220 ohms to that pin there, it connects. The inputs, that was the next thing to check, and one of them is tied to VCC, I think that one. It's tied to the VCC tab there, and the other one connects to one of the pins here, like either 13, 14 or 15 or something, somewhere around there, you should get short, and we do. So what we know is it's driving the LED signal here. For whatever reason it's not lighting. So I've just unclipped this, and these are super easy to do. When this is on here, like this, you just literally start on one corner and push the clips so that it unhooks, and you have to try and pull the metal part up just a little bit. As you unclip more and more and more of them, it becomes easier. I've shown it on the 3010 video. It's super easy. They're identical, it's the same keyboard, but you can see there's some liquid or something leaked in here, and it's probably going to be that's the issue. You can see here it's all over the inside of there, so I'll clean that up before we stick that back on. But right now I'm just going to carefully lift the membrane off. Oh, look how dusty it is under there. I think we'll vac that out as well. Yeah, the caps lock LEDs down here, can you see the contacts kind of look a bit oxidised and a bit dirty, so we'll clean those up. So just a little bit of IPA onto a piece of kitchen towel here, and we can just wipe and collect all this. Look at that, it's awful. Yeah, this position down here is for the LED, so just a cotton bud on a bit of IPA, just gentle wipe. Again, if that's worn off, you could recoat that with some of that carbon conductive ink stuff. Let's just see if we can just clean up around that, because it's a bit dirty around there. Another thing I would say is these seem to be pretty resilient from my experience. The problems occur here, they occur on these here from corrosion, having got into the edge thing there, and then when you pull them out, they just disintegrate. The surface of them just rubs off. That's the problem. And if you were to insert, remove lots and lots of times, then you wear them down. But you can, as I've shown on other videos, just trim, half a millimetre, just a tiny little bit. Try it. If it doesn't work, trim another half a millimetre, and then you'll find generally it works. But because there's quite a lot here to chop off, in theory you could probably go all the way almost up to the top. Don't do that, don't quote me, just measure it first. But then it becomes super tight trying to get it to to fit this in there. You've got very little room. If these are shorter, you've got very little room in between to get your fingers in there, try and reconnect them. Anyway, we'll just clean these other ones up here, but these LEDs are working, but it's not going to do any harm to give them a gentle wipe like this. So that's most of the dust removed there. Unfortunately, a spider set up home down in this corner of the keyboard here. Can you see this? And the vacuum is not bringing that off. It's like a really thick, sticky spider web there, just around that bit. So a little bit of IPA, and we should be able to scoop that out there. That's looking a lot cleaner now, I think. Just gently like that on the surface of those contacts, because those are what mate with that carbonised pad on the membrane itself. So if we just do that for each of them, then they should be a lot brighter, because that's the thing, you find these go really dim after years of just being sat there. They kind of get oxidised to surface. These ones aren't too bad. So here's the caps lock one. I don't know if you can tell, it does look very dark. Look how silvery the connections are there, and on the end here, just where it sits over the silicon bit, the rubber bit, they are super dark. Look at that, look at the difference. So hopefully that's all it was, a little bit of oxidisation, meaning it didn't make a good electrical connection with the membrane. And if we put the meter on diode test, I'm guessing it's going to be a diode rather than just a light, bulb. Measure it one way, 1.799. Let's switch it the other way. Should get nothing that way, I think. Yeah, and we can compare that to one of the others. 1.799, look, or 92. Nothing the other way. So I think the LED is probably okay. So finally we can get this back on. The caps lock is down in this corner here. And if we get it in the right position, I think it should, it should fit over the mounts and things here and pretty much just hold itself into position. I'll just clean up the underside of here with the wire brush and fiberglass pen and wipe it with IPA, and then we'll stick that back down. So I'll quickly clean that. It's not perfect because there's still a little bit of redness there. You really want to get rid of all of that, but that'll be alright. And it's got a little bit of light oil just on that little bit to stop it re-corroding. You can only get this on one way because those little mounts there marry up with those. So you just need to just carefully hover over, get it so you can see all the notches. And then on one side, just squeeze. You see that clip? And then this one here. And then that one. And just start to work your way across methodically so that you do each one on the way. Yeah, that's it. That's working. I freaked it out there by pressing keys while it was booting. Gave me some sort of keyboard error, I think. But the caps lock sorted. So let's give that a quick test. I've now got a copy of Pac-Man on an 880k disc, so this should work as well. I've only got one speaker connected at the moment. They sound great in stereo, and that's the nice thing with these 3000s. They have two speakers. The A3010 and A3020 only have one speaker, so you only get mono sound, unless you've obviously got it connected to a monitor or TV or something, or headphones out the back, an amp. But hopefully we should get some sound there from that one speaker. Yes. Sweet. The keyboard's working, as you can see. So there's little to do on this. There's just a few solder points that need reflowing. You can see one there was like a strand of wire that was coming through the wire and sat on the trace, and I just touched it literally with this and it just came off. It wasn't even soldered on. So I scratched off the surface of the trace, put a bit of flux on there, put the wire, tinned it first, then put the wire totally flat, and you can see that's soldered on. You can't move that now, that's permanently fitted on there. So there's one or two like that. There's one here, there's a few that I'll just tidy up in that way. There might be the odd thing that I reflow, but you know what, the soldering's really good on this actually. Whoever's done this, presumably Zarkos might have had a go at this one, it's very good. He's done an excellent job of this, considering how much damage there is and how many traces. He's done a superb job in terms of identifying and fixing every single one of those. They're all good. There's just the odd connection that maybe just needs a little bit of a reflow. Up here it's a bit dirty, so I'm just going to clean up with a toothbrush and some vinegar, I think, and then some IPA and brush it off sideways. So it's still a little bit dirty. I've been cleaning it up. Can you see these contacts here, the kind of greeny grey? To get the fiberglass pen on here, I need to extend it a little bit. And hopefully this should come back a little bit more solder-like. So final stages here. I fitted a CR2032 holder. I'll show you where I fitted the diode underneath. I removed the resistor from here. It was just crusty and the pad actually disintegrated. So it was on its last legs, that. I've reflowed lots of the little bits, you can see little strands of wire and stuff like that, because one or two of them they looked like they were joined and you could just literally touch it like that and it moved. It wasn't actually soldered on. The initial approach here is somebody has fixed lots of things that are obviously broken, but then started to fix things that look like they might fail. So that's why we've ended up with so many wires. I don't think all of these are broken. You know, if you look at all of these here, I don't think every one of these is broken, because some of the ones that I found that were floating, you know, like you say, some of these like that there, for example, you could move it. It wasn't soldered on, but it was through the via. So from the top side it could have been corroded, and just the fact it was through the via meant that it was okay. But I've soldered them on, you know, you can see I can't move that. I got some flux on there, and you know, cleaned up the trace, got some flux on, and then just reflowed it and made sure it's a nice solid join. So there are one or two like that. There's not many. There's a couple down here, look, that one, there's one there, and I've just, like I say, just reflowed them. There's a little bit of flux there still needs to come off, because I've just obviously put the CR2032 holder on there. And you can see where the diode goes. It goes from the anode, goes to the positive of the battery, and then the cathode goes to the little via that's down here. And that via, if you flip the board over, is the one that goes to the resistor I removed. They were slightly longer, these wires, and I've just trimmed off the ends and just made sure they are secure. They are secure. So, and again, there were some overhangs on these here, you know, they just came out a little bit on the ends, and just trimmed them off, so it looks pretty tidy. This whole lot has been IPA'd and brushed down and thoroughly inspected. There's another one there that wasn't quite flowed, and I reflowed that and put that in position, so that's nice and secure. So, yeah, there's nothing really wrong with the original work that was done, I would say. The one thing I don't like about this, I don't know if you can see, there's a little bit of wire there, but again, it's secure, and there's a little bit of wire there from this resistor. Well, it's like a 0-ohm link, isn't it? And that's secure. So, whilst I don't like them, and there's a few up here, can you see, on the keyboard? There's one there, that's secure. I think there might be another one somewhere, I can't see. There's one up here, look. But again, it's secure, I'm not going to move it. And there's one there that I had to reflow. You can see where my thumb is, just near that cap. So, yeah, it's pretty good. Well, it's very good. Everything's working. It's as clean as it's going to get, I think. As you saw, I cleaned with the fiberglass brush there. You know, these pads were looking green. Those are all cleaned up. Everything around here is clean. That diode's now looking clean. It's a bit copperish. The sides of the chips as well. You know, I cleaned around the sides of the arm, the IOC. It was a little bit dirty around there. So all that's been cleaned with a fiberglass pen, and then cotton bud and IPA. I used vinegar initially. I know this will have been cleaned with vinegar, but my first pass at cleaning was just all with vinegar, and then I used the IPA fiberglass pen, and then I cleaned off with the IPA again. So the way I'm doing this, as you can see, is surrounding it with paper towel here. What I don't want is it to go all over the board. I just want it just in there. Yeah, not on my thumb. Like that. So the reset switch in the past has had a bit of a knock. You can see it's slightly crooked, and the actual plastic piece is broken in two, so I need to super glue that in a minute. I'm not sure whether that's something to do with it getting knocked in transit or what. So I think I'm just going to gently heat the contacts from the other side and just try and straighten that out a bit. So I straightened that up, I'm now cleaning it. The way I did that, there's two ways. You can obviously just remove all the solder and then straighten it, and just solder a point at a time until you make sure it's straight. But I soldered all 6 contacts together into one giant blob and then heated it, and I could then easily just move the socket. And then afterwards, just then it took a bit of heat, wait for it to heat up again, and then just use the solder sucker to start to remove the solder, and then just reflow them all individually, which is what I've done. So as you can see, it looks, well, you will be able to see in a minute, it looks okay. It's nice and straight from the other side now. Just need to get that flux off there. We'll just have a go with the toothbrush to get in between. So I found one more of those little bits of wire that you can see it's coming through the via here, but you can move it. Yeah, you're not going to be able to see it very well, but trust me, it is not soldered. It's soldered on the other side, but it's not soldered on this side. So I'll scratch off a little bit of the trace, just scratch the via, and then just get some flux and flow that, just to make sure that that's stuck down. Yeah, I may as well put the good one on this one, because this one's good at the moment, isn't it? There we go. So before I get rid of any of these, I will be checking the power supply in every single one of them, but we'll revisit that perhaps in a later video. You can see there's a bit of corrosion here, that needs dealing with, and obviously if it's corroded here, the corrosion's probably got into the power supply. It might just be on the shielding, but it has got in there. The plastic clips are broken on the case for this to hold the board in, so the board will hold in place with screws, but as you can see the clip here is broken off. So I think that's it. So if we get this little speaker into the right hand side here, and it's quite nice the way they've done these, you know, it's like the right hand one goes to the right hand connector, the left hand one goes to the left hand connector. So I got 0 volts is black, that's your ground, 5 volts there. Yeah, the earth, that needs cleaning up, but we're going to come back in here anyways. I wouldn't just sell it as is. So I've got the floppy drive in there. I just need to secure it from underneath. So there's 4 screws, a bit like you get in the ST and Amiga. One thought I did have is the space here. You could use that for a battery underneath. There's enough space inside there. Maybe for one of those, the double CR2032 holders are used on the 3010s there. You know, it would clip on the inside. You could just tape it on the inside of the mouse port bay there. There is space for that, and it means it's easy to change it. You need pretty dainty fingers. My hands are pretty thin, you know, I've got pretty thin fingers, so this is ideally suited to me. And try and grab both sides and push down. You can see that's gone in. And then the real difficulty here is this one that gets in the way of the next one. So you've got to kind of pull it back before, and get your thumb around there before you push this one down. So again, you're gripping this here between your finger and thumb. And then again, this is super hard because there's very little clearance, and the power supply here is pressing right into my thumb. You've got to kind of push past the pane, try and align it, make sure it's straight aligned, push straight down. That's not in, let's try that again. Maybe that was in. Yeah, it was in. There you go, and just push down like that. Try not to crease the flex ribbon, but you'll see it's working fine. I find it actually helps if you put it upright like this, because you can see straight down into it, and as I say, you get the arrow towards the top there, and then all being well, it will go in. There we go, that's it. Yeah, it's just as annoying as the one on the ST, that. So I think we'll test one of these Acorn branded 1 meg expansions here. I've tested the other one already, I'll show you the other one, hang on. Yeah, so this is the other one. You saw me clean this up earlier, you know, these were red. It was furry and everything, so it came out super well after using some vinegar, toothbrush, fiberglass brush on the grade solder points there. It came up like new, and this one works. Now, I found this floating around in the case and thought it was off the motherboard, but it's not, because there was another one on here. This is the one off there. If you look at these, yeah, AKA 53 and then the serial number. So this sits on here, so I'm just going to stick these back onto these with a double-sided pad just to make sure they stay stuck. Now, I'm guessing this perhaps overlaid some of these here, because it's got the little marks like that, as if it sat, I think it sat there, look, like that. And just stick that down. That's not going anywhere now, is it? It's just a piece of history. It's interesting to see the difference between these serial numbers. That one's not stuck down yet. I'll stick that one down in a minute. There's very little. There's only just over 100 there. But I've got opportunity to show you how I cleaned the other two there, because I've got a third one here. I've been stripping these machines down to the bare parts, you know, like removing the RAM expansions or any other expansions in there. Floppy drives have all come out. Floppy drives have all been serviced. There's probably going to be some separate videos for some of those things, and it's the same thing with the keyboards. You've seen some keyboard stuff in this video, but there are a few different things, you know, different types of repairs and different techniques in another video. So, you know, initially I'm just using vinegar here, just crazy amounts, copious amounts of vinegar all over this. You can see how ready, rusty those are at the moment. You just wait until we're done with very little work, and you can see, look, it's coming off already, look, just with a bit of vinegar, most of that's coming off. So next, while I go with some IPA, I'm just cleaning the brush here, because you can see there's a bit of readiness there on that. So I've just dried that with a paper towel, and then we're just going to go, hang on, just extend the fiberglass brush out a little bit. The next thing to do is start to clean these, and again it's just a case of using the fiberglass pen here. There we go. That did take me 20 minutes, if I'm honest, but it's kind of AMSR. It was really good. So you can see, look how clean that looks now. There's no ready rusty bits on there, and it's the same over here on this one. I used the wire brush as well to get into the corners here. You may still be able to see a tiny bit of redness just there maybe. So you can use a sharp tool like this. Once you've gone over that like that, you could get some deoxit on a cotton bud, wipe around it, and then the thing I typically do with metal things like that is just get a cotton bud with some WD-40. There's a bit of corrosion there. Can you see that's looking a bit reddy on that side? Yeah, a cotton bud with a bit of WD-40 and then just wipe over it. That will just stop any corrosion starting again in future. Before we stick it in, we'll remove these two screws because they are what help hold it in. This is the one that hasn't been tested yet, so I'm hoping this works after having a clean up there. Just watch that speaker cable at the back doesn't get trapped. In fact, I'll just move it out of the way a little bit. Now let's try and press that down now. So I'm down on one side, look, down in the middle. There we go. That's into place. I've got an aftermarket one of these 1 megs still. But it'd be nice to send this one out to the world with an Acorn branded one in it. Sweet, so it says 2048. It does a quick test there, self-test on boot. I'm guessing if there was a problem it would have told us on boot probably. So I'm going to swap out the front. It's got something there that might be a bit of brown paint. But the main thing is it's missing one of the clips on the underside here. Can you see it's supposed to have these here, that overhang that hold the front on. But out of the spares that Zarkos sent me, there's a good lid here. It's just got some tape and muck on it, but it's good. There's no marks or damage. And then I think if we clip the front on first, probably, you sort of just pull it down and in, I think. Yeah, that's that. So I've probably got a podural bay for this somewhere, to cover this. But if we just try and, I think you've got to try and pull it back because it needs to go over the lip there a little bit. Come on. Yeah, like that. And then they just clip it in. And we just need to do the same thing with this side, just kind of pull it over the bay thing and then clip it in. It's not clipping very well, that, is it? Oh, there we go. Yeah, there we go, it's holding together. So we'll have a go at cleaning these up now. The one thing I'm not going to do on every single one, it'll be done as need basis. I'm not going to take every single key off and clean all the single keycaps up. What I have done is I've vacuumed the keyboard to get any particles off, made sure it's clean, and it is. It's not had any spills, but as you can see, it's a little bit dirty. So I would clean from the top here. I'll use the IPA on a rag like this to get any marks off. Hopefully that one there will come off. And I use cotton buds all around the keys, so I'll go up and down them, down the sides, etc. That's not come off there, is it? So they will be super clean to touch and use, but if you were going to restore one yourself, I'm talking about here, and I might do it until 1 or 2 of these, depending on how bad they are, then I will take off all the keycaps, wash them in the sink, etc. And it's a similar thing with capacitors. I'm not going to recap every single one of these because the amount of time I'm going to spend repairing these is going to be absolutely incredible. And if you don't believe me, have a go at fixing one of these yourself and just see how long it takes to get them up to the condition that I'm going to get these to. What I will be doing is identifying anything that does need replacing and replacing it. So we'll be having a look inside the power supplies, for example, on every one of these. And it may well be, if I start to see a pattern of a couple of caps in there that technically should just get swapped out, I'll swap them out. I might end up recapping all the power supplies. But the motherboards, the caps on the motherboards are generally very, very good on these. It's seldom a need to actually just go out there and replace them. Let's have a go at that main sticky mark there. So what I'll probably do is give this a scrub down in the sink, but I want to get these marks off first. So you can see it's still looking a little bit dirty here, and it's looking a little bit white here, you know, there's been a bit of pressure from the IPA. So I think the next thing I'm going to do is just try and get this a little bit cleaner, is get a little bit of plastic polish, just gently polish around here, see if we can improve this somewhat. Yeah, hopefully you can see what a difference that's made. It's incredible. This bit here is nice and shiny and glossy. All of the marks have come off there. So yeah, I mean, I will wash this in the sink because, I mean, that wouldn't have brought all this stuff off here, the sticky stuff. You need to use the IPA and the plastic cleaner to get those marks off. But there's lots of dirt in the vents and things here. So I will scrub it down in the sink to get rid of that. So whilst the lid is soaking in the sink there, we'll get the power supply out, we'll deal with this rust here, we'll have an inspection inside this one. We'll do the other one as well, just to make sure. Interesting, no serviceable parts within. That's lying! There are serviceable parts in there, just not user serviceable parts. Parts, if you know what you're doing, serviceable parts. Yeah, so that's going to need cleaning up. We'll get some contact cleaner into there, but just need to work out how to get the power supply out now. I'm guessing it's going to be screwed in from the underside. So the interesting thing with this is there's no screws under here to hold the power supply in, so it must be clipped in or slid in or something. But there's a battery flap there. If you remove that, there's two little slots for like 2 AA batteries. So I think they originally intended to put the batteries there for the motherboard. You can have the little tabs here and have a couple of AA batteries. It's a shame they didn't, let's get that dust out. It's a shame they didn't go down that road. So I'm having a look at one of the spare bottom units here that's just got a power supply in. So you can see they had two different types. One of them had this cardboard here, which, yeah, it's not a good idea because you can see it's been a bit heat damaged there. But trying to work out how to get the power supply out, I honestly can't work it out. Is it clipped on the bottom here, maybe? It kind of looks like that. Looks like it's held in with plastic clips or something. Yeah, I think it is. The question is, what's the best way to get this out? You have to peel this hazard sticker off here. Look, it's coming to pieces, this. I can stick it, I was going to say I could try and stick it back to together in a minute, but it's ripping. We'll just tape it back on afterwards. But if we just, in fact, I'll glue it back on and then tape it back on. Yeah, there's a screw here in the middle of the PCB. Now, on that other one, it's going to be the same, I think. It's just a much larger sticker, as you'll see. If we pull that out, then we can get it out like that. Now, on this one, you can see where the cable is clipped on. That metal one, I'm not so sure because it's kind of all in a can. God, that's hard to go. That's it. So we'll have a look at that one in a later video, maybe. The main thing is it's out of there. We can test it, repair it, maintain it, etc. So back over to this one. I'm inclined to not want to remove that whole sticker. Actually, you know, trying to peel this whole thing back here, it's just going to make a mess. I might just get a craft knife and just cut this a little bit so I can peel a little bit off. I think there's some sort of clip or something here, maybe. I don't know, I can't really tell. So I just sliced a little line here. I'm going to see if I can get the knife underneath here. Yeah, looks like we can. Just carefully. And I think the other thing I'll do is just slice this way. Yeah, I've got extended quite a lot of the blade there. Shouldn't really do that, I could shatter. Just pull it like that there. Yeah, there we go. That's what I was aiming for. So it looks like, yeah, there's a screw at the bottom there. So let's get that out. And it's just lifted out now, I think. So the final thing here, well, the shielding's coming off. Look, that's good, I think. Is it coming off? Yeah, it is. So let's just put the shielding there a sec. As I've said, be careful you don't electrocute yourself, because the caps on here can hold a fair bit of DC for a long period of time. So I need to try and get this carefully out of here now. Speaker's trapped on there. What's that wire there? Oh, that's the floppy drive wire. So the first thing we can do is just inspect for any bad solder points, but you know what, that's looking pretty pristine. I'm not seeing anything obvious on that. That looks pretty good, actually. We can detach the shielding, that spade connector there, look. Just make sure we get these the right way around. Yeah, that's the outer one. Yeah, there we go. That's that detached, and we can have a look around the power supply here. So, I mean, we're just looking for leaking, bulging caps and things. Bear in mind the ESR could have gone high on some of these. You know, they could be acting as resistors. But I don't think we're going to need to do anything to this power supply. But, you know, you might want to consider recapping one of these. There's not a lot of caps on it, actually. You've got these 4 electrolytics here, and 2 over here. That's pretty much all you would need to consider swapping out one of these. One thing I don't like, can you see the bridge down here? Look how long those legs are. They're crazy long. Quite why it needed legs that long, I don't know. But then again, it's standing away from the board, it's kind of away from everything. It might help with heat dissipation a little bit. So yeah, there wasn't a massive amount of dust. You can see just one cotton bud's worth, really. Other observations, you can see this wire here. It says on it 220, actually, on the orange label there, and you can see on the board there it's marked 240. And over here, can you see up there? We've got one that says, sorry, I'm off camera. One that says 120. So you could configure this, you know, put that over there to 120. I don't think any of the changes would be required. You could use this in the US or somewhere that's got, you know, 110, 120 volts supply there. Little trim resistor down here, you know, variable resistor here. It probably adjusts the 5 volt level, that I would think. So, you know, you could connect this up, measure the 5 volts out of here, and then probably just tweak that one way or the other just to get a fine adjustment on the 5 volts there. It's a nice little switch mode power supply, this. I think these are probably reliable. I don't know. Post your comments down below if you had lots of these fail. I might have seen one of these faulty in the past, I think. Just thinking back where the switching transistor went, but they're probably reliable because everything's fairly spaced out. The negative side is if you've got the one with the metal can, it does enclose it quite a lot, which keeps the heat in there, but everything is pretty well spaced out. It's there's lots of room on there. It's nice the way they've laid it out. So on the underside here, yeah, you've not got like a massive amount of isolation, but you have got cutouts here between the primary and secondary side of the transformer. So yeah, it's not bad. The solder points, like I say, are looking really good. So I think we'll just reassemble it now and give it a test. You could swap out the switch as well if that switch is giving you any grief. Although looking at it, it's extended back a fair bit, so I'm not sure how easy it is to find a switch like that. This style here, super easy to find, but with this extended back bit here, I've not seen one like that in a while. I don't think. I'm not sure. And again, just a point of interest, I guess. The large caps, can you see? 2 large caps here. Yeah, these are the ones that are going to hold the rectified DC. If you measure across that on volts DC, you can see we've got nothing. This has been powered off for a week, so yeah, it's lost its charge within a week. Other things you can do sometimes to drain power supplies is when you've unplugged it and you're taking it to bits, before you take the power supply out, switch it on and then switch it off. That can drain some of the caps sometimes. So then the final thing you might want to do, obviously be super careful, don't put your hands under here when you're trying to get the power supply out. Measure the voltages on there. If you've got a voltage, just short them across like that. You could bleed it away with a wire wound resistor on a wire or something, but you know what? This is the technique I was always shown, and I've done it so many times to so many thousands of devices. it never causes a problem just shorting them like this. You'll see a spark, you know, obviously don't be touching the handle, have something that's isolated and just short them like that to drain them if they've got any charge. And something else just to clarify, because I know sometimes I throw these terms in and I don't really explain them. The primary side is where your high voltage goes in. Yeah, the secondary side is your steps down to lower voltage. You've got lower levels of AC coming out of this transformer here. In terms of what goes in, technically with transformers you're feeding AC, but it's kind of not. I think it's kind of like switched DC. You know, the switching transistor here puts a high frequency pulse into here. That's where you get the power benefits of having that high frequency pulse. Instead of a continuous amount of power going into it, it's switched, you know, I don't know, 100 kilohertz or something. I'm guessing that's probably how this works. I'm pretty sure that is the switching transistor. So yeah, your secondary side is here. You know, this stuff on this side here is the secondary side. This side's the primary. That's probably an opto isolator there, I think. Yeah, look, it's that's between the primary side and the secondary side. You have opto isolation between the two. So this is kind of usually used, I think, as the feedback mechanism. You know, so it can control or completely stop the switching here in some power supplies, so that it doesn't overdrive the output. But typically, you have some sort of voltage comparator stuff going on here somewhere, and it sends the feedback over this, opto isolator. It uses an optical, beam of light from one side here to receive on the other, like a transistor or something on the other side that's affected by the beam of light on this side. So the intensity of that light, depending on how this is performing, the voltage's output affects the transistor on this side, which can, let's say, control the switching here to reduce or reduce the frequency or increase the frequency, so that your 5 volts remains where it should be. And actually, before I get criticised for that, it's not the frequency that probably changes in order to get the voltage just right. It's the PWM, pulse width modulation. The duty cycle changes a little bit there to accommodate that. It might change the frequency as well. I'm not 100% sure, but anyway, that's just a basic explanation of that. So sorry I had to bring the video to an abrupt end there. We were starting to run over an hour and there's still quite a lot more footage yet. If you do like watching the channel, please consider donating $1 a month via Patreon. It just means I can continue to do these videos. Without Patreon support, there would be no channel as things stand. So thank you very much. I hope you found the video interesting. Catch you in the next video.